Okay, welcome everybody. This week we have physical scientists Mike White and Derek Sowers from the NOAA Office of Ocean Exploration and Research. They'll be presenting on Okeanos Explorer's 10-year history, as well as some highlights from last year's field season.
Great, thank you. Hi everybody, I'm Mike, that's Derek. Just want to welcome you all here and thank you. Oh, what? You need just want to introduce the rest of our team, Mimi, Mashkor, and Shannon. Charles, we have under here. Charles is actually not part of our OER mapping team. He's actually our senior survey tech on the Okeanos Explorer, but of course, everything we'll be presenting today, he's been heavily involved with. Just to give everybody a brief kind of faces to names, Mimi Lobecker, Derek Sowers, myself, Shannon, who just joined the team, who's sitting up here, just is also still a student at CCOM, finishing up. And of course, Mashkor Malik. I should note Mashkor was the first physical scientist for OER back in 2009, and he actually works down in Silver Spring. The other four of us are all based here at CCOM back in the NOAA cubicle farm back there. So if you ever see us around campus and you want to learn more about what we do, or you're interested in the Explorer and Training Program, or you have a survey of opportunity you would like us to address, please come seek us out. Just a brief presentation outline for today. We're going to give a background on NOAA's Office of Ocean Exploration and Research and the NOAA ship Okeanos Explorer. We're going to go through that pretty quickly since many of you are familiar with our program and what we do. Derek's going to focus on 10 years of ocean exploration, our accomplishments. This is the 10th year our office has been sort of commissioned to do ocean exploration. We're going to really kind of the bread and butter, the highlights from our 2018 field season, and of course what 2019 looks for us and some mapping equipment we're looking to upgrade and integrate. So I don't probably need to tell you all, but we like to start out that ocean is big, right? And the places we go for weeks at a time without seeing another ship on the electronic charting display. You know, the ocean is a very large place, and much of it, of course, remains unexplored. And that's not just the high seas area. You know, we think about the United States Exclusive Economic Zone, or EEZ. We think about places off of Hawaii and the Hawaiian Islands, places off the West Coast, deep water areas off the Aleutian Islands, the Marianas down here, Kingman, Palmyra, down to Jarvis, Howland Baker Islands, American Samoa. These are a lot of places within the US EEZ that have a real sparsity of deep water information. And depending how much or how you define mapped, right, whatever sort of sounding you have over some sort of linear distance, I think we can safely say anywhere between 85 to 90% of the deep ocean remains unmapped, and less than 1% of that is unexplored insofar as that we have images or we sent robots down there or we sampled it, right? So the deep ocean largely unexplored, which is of course where our office comes into. We're the only federal organization, we sit within NOAA, we're the only federal organization dedicated to exploring our unknown ocean. Our office supports different innovations and exploration tools and capabilities. We of course encourage the next generation of ocean explorers, scientists, and engineers. One of our goals is, because we are a federally funded, publicly funded office, we provide a foundation of publicly available data and information to give resource managers the information they need to make informed decisions, right? And think about that logically. Nobody can make informed management decisions, decisions about sustainable management of the seafloor without having the data in front of them. And that doesn't matter if you're, conservationist or interested in deep sea resources. We're going to focus today on our dedicated ocean exploration vessel, the Okeanos Explorer, but we just want to note that's only a part of what the Office of Ocean Exploration does. We also provide federal funding opportunities. These are competitive grants to fund innovations in exploration and research. We have a number of cooperative agreements. We work with a number of cooperative institutes. We have a number of partners, both within academia, the commercial world, and of course, other federal and state agencies. So while Derek, Shannon, and myself, Mimi and Mashkor, of course, support the Okeanos mapping side of things, our office is larger than just the Okeanos itself. Why do we explore, right? And many of us here intrinsically recognize this, but of course the health of the ocean is linked to so much of our lives, right? We're thinking about weather and climate. We're thinking about sustainable management of deep sea resources. We're thinking about fisheries. We're thinking about energy. We're thinking about the preservation of the diversity of life, right? All the, even the deep parts of the ocean parts that we're exploring, right? These are intrinsically weak to the success of current and future generations. A couple of principles of exploration. Main objective is to achieve a first-hand characterization of a site to enable follow-on research and hypothesis-driven research. We are mission-driven. We are not principal investigator or hypothesis-driven, right? We have an objective that we're trying to achieve. Our investigative team participates on behalf of the entire scientific community. Derek will get into this a little bit, but we are a community-driven exploration platform. As I mentioned before, all the data and results of an expedition are publicly available to anybody. That means you all, that means the general public, that means other folks in government, academia, commercial entities. And of course, one of the things we try to do as an office is engage others in innovative training, education, and outreach, and we'll touch on all three of those things later today. So many of us who've gone through high school, college, master's, PhD, research science, right? First, we have an hypothesis, right? We're thinking about why something is, how it could be. We do some sort of research, have some sort of independent, dependent variables, some sort of control, right? And then we try to provide answers on that hypothesis based on our observations, based on our research. Exploration is a little different in that we do exploration and reconnaissance. We discover new things, and hopefully what we discover then drives hypothesis of why things are, how things came to be, why things are where they are. So exploration is a little different as opposed to hypothesis-driven research. Introduce you to the ship. NOAA ship Okeanos Explorer, also colloquially known as America's ship for ocean exploration. It is a formal naval surveillance vessel, which means it's very quiet, great for our sonars, a Teagles-class ship, USNS capable, recommissioned in 2008 as a NOAA ship Okeanos Explorer, and is a dedicated remotely operated vehicle and mapping exploration platform. Currently, it is en route to Pascagoula, Mississippi for a dry dock. As I said, we're a community-driven exploration office and platform, and of course, we work with a number of organizations. Two out there are the Schmidt Ocean Institute and Ocean Exploration Trust. They, of course, support the ships, the research vessel Falcor and EV Nautilus. All three of these ships, including the Explorer, have very similar mission goals in mind. Go out there, primary site characterization, reconnaissance, some sort of primary observations. And we work a lot with these groups, sharing data, sharing ideas, sharing emerging technology. And one of the things we do work very closely on is our yearly oceanography supplement. Last year, they're all along here. Please feel free to take. We're just finishing up our 2018 field season summary for all three exploration ships that are featured in this article. And of course, all the cruises Derek and I will mention during this presentation will be available in next year's oceanography supplement in greater detail. Our mapping systems on the ship. First, we have a Kongsberg E302 with water column backscatter options, a half degree by full degree system, pinging at around 30 kilohertz. This allows us to develop the high resolution 3D images of the seafloor, as well as derive multi-beam backscatter. Since the commissioning of the ship and since the inception of our program, and of course working closely with folks from CCOM, we've been doing this additional examination of the EM302 water column data, picking out things like seeps, picking out things like objects within the water column itself. We have a suite of Kongsberg EK60 split beams. These are pinging 18, 38, 70, 120, and 200 kilohertz. We don't often run the 38 kilohertz with the multi-beam due to interference, but these will give us some sort of idea of the structure of the water column itself, enable scientists to quantify biomass in the water column, possibly quantify bubbles in the water column, which we'll touch on in a little bit. We have our Knudsen 3.5 kilohertz sub-bottom profiler. This allows us to look beneath the seafloor. And these three sonars, the multi-beam, the split beams, and the Knudsen, we run in conjunction with each other. When we're completing mapping operations, all three are on at the same time. And then finally, we have two Teledyne ADCPs picking at 38 kilohertz and 300 kilohertz. These gives us a sense of direction and speed of water flow under the ship. We use these in a very operational sense, in that if you put some multi-million-dollar assets, i.e. our remotely operated vehicles into the water, you want to know which way they're going to drift. Sound speed profiling tools, obviously having accurate sound speed casts within the water column itself is important for sound propagation, important for beam steering, right? How we work our multi-beam sonar. We have an expendable bathythermograph XBT, and we just, this year was our first year we fully integrated our auto launcher. This was actually built by NOAA AOML. It was originally built for transit ships or container ships to allow to acquire temperature profiles in the water column. We've integrated so that when we're on a night mapping watch and maybe we only have one or people awake, then they can just sit in the control room, press a button, launch the XBT probe, and they don't have to go outside in the dark of night, or if it's unsafe conditions, of course, in the fantail. And this year, we're looking forward to integrating our underway CTD. The nice thing about the underway CTD is that it can complete it while the ship is moving, similar to the XBTs, but of course, it uses a reusable probe, so we're not continuing to expend XBT probes. This year, we also fully integrated within our workflow sound speed manager through HydrOffice tools. So this allows us to apply salinity to our XBT profiles. It also exports the locations of where we've done our profiles. One of the wonderful things working here at CCOM, we of course, when we have issues or we need to integrate a new type of file format, we can reach out to Giuseppe and say, Giuseppe, we need some help coding here. And so it's been a great, very positive relationship we've had integrating a sound speed manager. We maintain, by we, Office of Ocean Exploration, in partnership with the Global Foundation for Ocean Exploration, which is a nonprofit entity, maintain 2 remotely operated vehicles as a dual body system. The first is Sirius, which is a light and camera set. It essentially insulates D2 from the ship's eve. D2, or Deep Discoverer, is our is the ROV. You actually see that as a white top, has that foam pack on top. This is the one where you typically see the video feeds from shore, and also gathers a high resolution video and images we'll see. And we do have some limited biological and geological sampling. We're looking to expand that in the future. Telepresence. We have a high bandwidth connection through satellite VSAT connection, very small aperture terminal. Telepresence allows us, when we have the ROVs in the water miles below the sea surface, to stream in almost real time the videos we are seeing on the ship through the cable up to the satellite and down on shore, where scientists on shore can help us within 10 seconds of seeing, say, a new coral species, help us identify if that is indeed a new coral species or not, if that species of sponge is worth sampling, if we've never seen this fish before. So it allows us to, as a force multiplier, bring on the onshore expertise to the ship. It also allows us, from a mapping standpoint, to almost every hour send our full resolution raw mapping data sets and full resolution products to shore, where it can be examined by decision makers and managers on shore to adjust our coverage in real time. And wonderful thing about telepresence is it's not just scientists and engineers who can share the discovery in real time. There's, of course, you all, the public, yourselves.
Snail is spinning. Snail peeking down. Oh my gosh.
Say.
All right, so thanks, Mike, for that great overview of our program. Apologies to those that have seen that a few times. We're going to talk now a little bit about our kind of 10-year look back. We've been in operation running the Okeanos Explorer for ocean exploration for about 10 years. So real quickly, a few highlights of what we've been able to accomplish during that time. About 99 exploratory cruises completed, 1.79 million square kilometers of seafloor mapped, and I'll give you some perspective on how big that area is. A track line of coverage while we were mapping that's about 9 times, equivalent to going around the Earth about 9 times, so we've covered some ground in those years. Over 4,000 XBT profiles, so those are individual temperature casts of the water column. 259 CTD casts, over 425 successful ROV dives, which is and we have a very high success rate, a very high safety rate with those vehicles, so operated very professionally. Over 1,500 specimens collected for science, so a lot of, we've only had collections going for a few years, but we've been able to really gather a lot of biological and geological specimens for further analysis. And nearly 20 million views of OER video through both our primary feeds that we manage, as well as sort of people that push out links to our feeds. So really start to get a feel of the number of people that get to kind of engage in ocean exploration through the outreach work. This is an overview map of what we've mapped during that whole time period. So just to highlight some of the things here, you can see a lot of work down on the Gulf, a lot off the East Coast, particularly in the Atlantic canyons, and some work on the Blake Plateau. Some recent work further out in the Atlantic, up in the New England Seamounts chain. The Puerto Rico has been a big emphasis area for us. You see transits going through the Panama Canal, always mapping typically during a transit to gather data. A lot of work off the West Coast. And then these are small inset boxes, but they really represent huge areas. We did a huge expedition out to Indonesia. A lot of work around the Mariana Trench out of Guam. Hawaii, we operated many cruises to Johnston Atoll, the Northwest Hawaiian Islands, Musician Seamounts, and around Hawaii itself. And then out of American Samoa, we did a series of expeditions for Kingman, Palmyra, Phoenix Islands, Howland Baker Islands, which are US controlled territories. So just a really vast area all over the world. If we were to take that equivalent land area and show you mapped on the contiguous United States, all the area in blue kind of gives you a sense of the seafloor coverage that we were able to obtain during that time period. So pretty large footprint for 10 years of work. It's the beauty of deep ocean mapping. Also, I wanted to highlight as a 10-year look back, just that we've had a training program really important to us. Through the mapping team, we've started a sort of an internship program where we give undergraduates and graduate students opportunities to get at-sea experience in ocean exploration. So this is hands-on, taking people to sea, training them on how to run the system, acquire the data, process the data, and get that full experience of being at sea. For many people, it's their first at-sea voyage, so it's a great resume builder. And we've also expanded the program. So you can see 122 people affected by this so far, which is, I think, a pretty good rate for a hands-on experience like that. We've also added an onshore component in recent years so that people can utilize the telepresence room here at UNH. There's an exploration command center upstairs. So you're sort of virtually participating in the cruise. They've been able to stand watches while the mapping data is coming in at sea, clean the data here within about an hour or two of data collection, and create some value-added products that we don't have time typically at sea to generate. And then obviously take advantage of the expertise here at UNH. We have training seminars. We've been visiting the Gulf Surveyor a couple times. So nice onshore component. And then of course, offshore is where you really get out, and people often really want to get out there and do this. I should emphasize that these are for mapping cruises. We don't have enough room on the ship, unfortunately, to take people on ROV cruises. So a question that we often get asked for our office is, how do you guys decide where to go, what to explore, what are your priorities driven by? And it's not a quick answer, but the big thing to realize is that we have a lot of partnerships that are both national, international, as well as with many different parts of the government and academia. And kind of we have workshops, we have all these initiatives that we collaborate in with other people that help drive our priorities. So some of the main driving priorities for us right now are these campaigns, learning about deep sea corals, Seabed 2030, which I think most folks are familiar with here. There's a deep search effort, which is a multi-agency, large effort to understand coral and canyon habitats and seeps down off the southeast US. So we're involved with that, giving ship time. The Galway Statement, Mike will talk a little more about that. That's a trilateral agreement on the North Atlantic. Extended Continental Shelf Program, we'll show you some collaborations there. And right now, a big driver for us is this Aspire campaign, Atlantic Seafloor Partnership for Integrated Research and Exploration. So that's really this multi-year effort with many different ships, not just the Okeanos Explorer, and many different agencies, really focusing on getting a better handle on resources in the North Atlantic for many different management science purposes. So packaging these things in sort of campaigns that everyone can kind of share broad objectives helps bring partners to the table in terms of ship time and financial resources. For the 2018 field season, we're going to just run through some highlights. I'll be talking about a few cruises I was on, and then Mike will go through cruises he was the mapping leader, expedition coordinator for. So this is what we were able to accomplish last year. Just to note, we came back from the Pacific. We were over there for about 3 years doing work. Came through the Panama Canal and up. We did a series of cruises in the Gulf of Mexico. We worked off the Blake Plateau down here, up into the canyons, and then did some offshore work. This is of interest to the extended Continental Shelf Program. And then this is a Galway project out here. And we did a cruise down in Puerto Rico as well. So that's kind of the quick recap of 2018. And we'll just walk through some cruise highlights. I was involved, and Mimi Lobecker, who's not here right now, she led a mapping cruise in this area. I was on the ROV cruise. And you can see the kind of more opaque data is existing background data. This was collected by Extended Continental Shelf leadership from UNH. Some of this background is from other Okeanos Explorer cruises. And then the kind of brighter bathymetry is what we accomplished on these 2 cruises. It's worth noting that the Gulf Stream axis kind of runs through here. So a lot of the really interesting priority areas for managers to understand is kind of fed by the currents and the food brought by the Gulf Stream, but it also makes it very difficult to map and do ROV dives there, as you can imagine. So that's where we focused, as long as the edge of the Blake Escarpment here, and then up into the canyons again. Couple interesting features to point out down in that region. This is an area called Stetson Mesa. It's got this really complex mounding terrain. This is the kind of features you can only resolve from a ship when you go out and map, or not from satellite altimetry. And when we took a closer look and dove on some of these features, this is an ROV track up one of these features, what we found was dense colonies of reef building Lophelia pertusa, which is what this is right here, and it forms these huge mats of coral. So all the way up this was just coral rubble fields, and then at the top you find the living coral. And so they're likely building these things over hundreds, if not thousands of years. Other things that we saw here was the Blake Escarpment. This is kind of coarse bathymetry, just a gentle slope. When you map with the multibeam on board, we found these very distinct ridges and scarps. And when we dove on these kind of interslope terrace features, we did find that they provided substrate for corals and sponges and pretty diverse community. Another area we went to is we noticed these more linear ridge features. And we planned dives on along these as well. And these turned out to be very dense Lophelia and coral colonies as well. So one of the questions is, are these built mostly by just biology building up over time? Or is there some sort of underlying geology that then the biology kind of builds up in higher relief? So more questions to be answered there. And then another feature in the Blake Plateau was really these prominent scarps all over the place, really interesting terrain. And we were able to pull off some dives on some of the steeper ridges looking for exposed substrate. Typically, we're looking for things that are steep and hard so that we can look at the biology that's growing there. Mike, if you could roll this clip really fast. This is from the mapping cruise we did in this region, just to highlight some of the interesting seafloor features you find here. Really complex, fine little ridge features. They seem to be sort of oriented. I think these were with the Gulf Stream. So this was from Mimi's cruise that she led, but I don't think there was a single ROV dive on this. So these have sort of a different morphology than the other mounds we've been able to dive on. So a lot of work to be done, a lot of questions about what are those formed by and what lives there.
You're on the water depth?
I think they're around, I want to say 700, 800 meters, 600 or 700. Yeah, somewhere in there.
Meters.
Quick highlights from the Puerto Rico cruise we did this year. So we've done previous cruises down in Puerto Rico. This kind of added to that. First, the mapping footprint that you see here is roughly about 1.5 times the land area in Puerto Rico. So we were able to get a lot of mapping data accomplished. We did 19 ROV dives. As you can see, these white dots spread all over on a variety of features from 250 meters all the way down to 5,000 meters. Unfortunately, we didn't get a dive in this new area that we were able to map, which is really fascinating. Just to highlight that, I'll show another slide in a minute. We're not going to have time to run through ROV highlights from all these cruises, but just so you're aware, we do look, there are scientists that look at the density and the diversity of habitats that we're exploring. We did find a number of high density communities, a lot of high diversity sites that we were able to find with the ROV. And all of these observations are geotagged and logged in the database, so they're searchable by other scientists later on. We did some dedicated sort of geology dives on the Mona Canyon and Mona Seamount area. And then I did want to highlight that we also look at the midwater, so it's not just seafloor exploration. Obviously the water column is a huge habitat on Earth that's very poorly explored. And so we've been doing actually designated dives within the water column at we'll do transects through certain water depths and then move down to another depth and explore. And just really focus on getting good imagery of what's living there and happens to be not scared of us. But we find tons of fascinating creatures and new observations, new insights. Yeah, so this area down here, just wanted to highlight just a fascinating area of steep canyons, and there's no deep sea submergence exploration of this done yet, so still great opportunities for further work down there. And we did actually get into the Dominican Republic for a while. We were able to map this whole Engaño Bank feature, which is really cool. And a note on that a lot of the dives we do with the ROVs, we're typically finding either range extensions for species where we didn't know they were in this part of the world, or we didn't know they were at this certain depth zone that we're exploring. And often we find new species that we believe they're not described by science yet. So new species, obviously we have to do a lot of legwork with taxonomists to prove these things, but that's pretty common for deep sea exploration work. I'm going to pass it back to Mike, and he'll review some of the highlights from cruises he was heavily involved.
So we had 3 cruises within the Gulf of Mexico this year. 2 were mapping and ROV cruises, and 1 was an emerging tech demo cruise. The cruises and the mapping data, the ROV dive sites, all of these were within the US EEZ. So this is all focused within US waters. Gulf of Mexico is a really interesting place to work, especially since we just spent 3 years in the Pacific. There's a tremendous amount of data down there relative to where we'll be working in this data. Some of it's proprietary, some of it's, of course, other data from other federal agencies. This year, we leveraged the BOEM 3D seismic bathymetry that they had recently assembled this year. And down in the Gulf of Mexico, we were doing a variety of things. So the first step we have to kind of go through is sort of leveraging existing data. And this just isn't mapping data. This is where we've had other remotely operated vehicle dives. This is, of course, where there's oil and gas platforms in the industry, right? And so this is a big step. One of the things we go through on shore is data mining. Where are these things? Geospatial data, mapping data, and all of that. And this is sort of answering, like, we want to explore new places, right? And we don't want it to be doing research on kind of where dives have already begun. A lot of our Gulf of Mexico work for this year was focused towards habitats or habitat areas of particular concerns. And a lot of our data was looking at extensions of protected areas, a lot to inform management within the Gulf itself. And the Gulf is also a really fascinating place. One of the things we were doing, also working with our colleagues from BOEM, is before industry does any sort of research extraction, they have to do high resolution surveys down there. And so we had a number of dives in there. There were underwater cultural heritage dives or shipwreck dives. We were working on getting photogrammetry of these shipwrecks, 3D photogrammetry of these shipwrecks. And of course, the Gulf is also quite famous because it has naturally occurring, hydrocarbons, methane, and tar that actually naturally leak out of the seafloor, out of these salt diapers. And here's a fun video of bubbles.
Oh, bubbles, right there.
So this is the voice of Diva Amon. She's one of our senior scientists on the ship on this cruise.
Methane hydrate forming there. And so if you're just joining us, methane hydrate is sometimes called methane ice, and it's a frozen form of methane and water that forms at relatively high pressures and low temperatures. This gas hydrate is stable at the conditions we find at the seafloor in this part of the Gulf of Mexico, and it's been found in many places here, particularly under overhangs or as seafloor mounds.
This is so beautiful. You see here,
This is the voice of Carolyn Ruppel. She's from the USGS. She's actually on shore narrating this video in real time.
As we watch and then we need things, there's a fight here, and nothing. Really phenomenal. Thank you so much for this program. Beautiful.
So again, leveraging our telepresence technology, right, working with scientists onshore to get better video, better imageries of where we haven't gone before. One of the experiments, one of the emerging tech demos we did down in the Gulf was, this is the dome area, Biloxi Dome in particular. We had collected quite a bit of mapping data there back in 2014, 2015, I believe. And along with the mapping data, we also identified some seep targets, methane seep targets within the sonar water column itself, the EM302 and the EK60s. And on several of these, we sent the ROV down, so we knew these were confirmed seep areas. One of the things we did this year in conjunction with Liz Widener, who's sitting in the back here, she actually came out on the ship with us. We generously borrowed some WBTs, or wideband transceivers, from CCOM here, put these on the ship, replaced our GPTs, and then hooked them into our ES-18, or really it's an EK-18 transducer with on the ship. And essentially the ship was just drifting over Biloxi Dome, collecting this data, but what you can see is, we have the ambient noise, but within that, you can pick out where these scatterers are rising through the water column itself. And again, I want to thank Liz for providing these slides. And you can see, right, where these scatterers are coming up within the water column. And if you can, with a split beam sonar, you can actually track them through the water column. You can begin to quantify how much methane or how much material is actually degassing from these seep areas. If you want to see additional, this is all Liz's work. So if you want to see additional research on this, go see her talk at the GRC. But it was great to have her out here. And the EK WBTs, the EK80s, are something we're looking to integrate on the ship later this year. Derek talked a lot about our mapping data and how it's used in a scientific sense, excuse me. But one of the things we do with the mapping data is we use it in an operational sense in real time. And so this was a dive, or here's our dive location right here, is actually a shipwreck dive. And it was about within 1.5 nautical miles of one of these oil rigs. And that can present some technical safety issues for us, since many of these are floating rigs and are actually moored to the seafloor. So we were able to work and get, where the pipelines were on the bottom. And this is interesting because keep in mind, those remotely operated vehicles are tethered to the ship. And so we're always worried about entanglements. And we knew where the oil rig was. We knew we actually received where the mooring anchor points were on the seafloor. And so the question was, well, could we see the actual mooring chains, which is within the EM302 water column data itself? So at about 3 a.m. in the morning, we were sitting in the control room trying to tease out these mooring chains. And it was especially difficult since we were only able to get so close to the oil rig. They were almost in the side lobe interference. But what we did was we actually were able to pick out exactly where these chains were in the water column within the EM302 data, provide that to the ROV team in less than 3 hours. And so now we can say, okay, we can dive here, and if we have to bail out on an ROV dive, keep in mind that if the vehicles go dead stick or something, the ship can go this way, this way, this way, but we don't want to be going towards the rig and hear exactly where those chains are in a 3D world. Next cruise we want to switch out to is our mapping deep water areas, southeast of Bermuda, in support of the Galway Statement on Atlantic Ocean cooperation. The Galway Statement is a trilateral agreement between the United States, Canada, and the EU, recognizing the Northern Atlantic Ocean as a shared resource. And again, the success of the Atlantic Ocean linked to the success of these three partners. This was actually the first cruise done under the auspice of the Galway Statement that was a government-supported non-transect cruise that actually incorporated some focused mapping time. So we were out here about 250 nautical miles south of Bermuda, and we were able to map this entire area about the size of Massachusetts. And we were lucky / fortunate / really excited to find that this area was not just boring abyssal seafloor, but indeed contained some really fascinating features. And so this included some null features, cone field here, evidence of some sort of secondary volcanism, some ledges and escarpments associated with these northwest, southeast trending divots or some sort of faults or ridges here. And of course, we also found a true seamount, as the feature is actually 1,000 meters above the seafloor. And this was really exciting because, when we were engaged in our Pacific campaign, when we go out and do these ROV dives in the remote ocean, these are the types of features, especially the tops of these features. These are the features we'd like to dive on because that's where the corals are, that's where the sponges are, that's where we see these, diverse high-density communities. So seeing a feature like this, was a pretty incredible experience. I should note that this area was identified by the Atlantic Seafloor Mapping International Working Group. Some of the representatives are, of course, here at CCOM. as sort of a high priority area because it did not contain a real paucity of data. It may have been some sort of environmentally sensitive in some way, or these areas also may contain some sort of marine resources. So this is one of the priority areas identified by the AMSLIC members. One of the other things we're doing on the ship in real time, and something we just want to touch on, is we are field processing backscatter here, and we actually had a visiting scientist on board that was looking at this backscatter, what she called bright flows. Since Galway is a national agreement, she's actually from the University of Kiel in Germany, Tatum, and she was looking at where we had these evidence of secondary volcanism. And then she was looking at the backscatter around these bathymetric highs, and she could see that the backscatter around these highs had a higher return. Means maybe it was more recent than the other areas around it that may have been more heavily sedimentated. And so here she was picking out areas where new seafloor could be forming independent of, say, a island hotspot chain like Hawaii, or independent of a seafloor spreading center. So really interesting work that was going on the ship in real time on this group. So I apologize, this image finally came in. So here you see the bright flows, right? And these are associated with bathymetric lows around a feature, like some sort of volcanic feature, right? Associated with the bathymetric high. And next we have our cruise in support of the Extended Continental Shelf Project, or program within the US. This cruise was actually originally planned north of the Lake Spur, but within a couple of months of planning this cruise, it became evident to us through our partner agencies that these polygons down here represented a higher priority area, again, leveraging our community exploration aspect. And because these were actually active areas where some negotiations were going on in between Bahamas and the United States. And so this is one of the wonderful things being at CCOM is we were able to leverage the existing ECS data. So I walked down to Jim Gardner's office. I said, okay, what are we looking for? I was working with Andy and of course the other folks in the ECS efforts. And one of the things we do go through here, and I'll just highlight it, is we leverage existing data, right? We're the Okeanos Explorer, not the Okeanos, let's go out and remap it, right? So one of the things we did was, we recognized there's existing data here, some existing 122 data. You see this big stripe in the survey here. This is not where we fell asleep or my line planning went poorly. That's where we had existing data, so we don't need to take time refilling that in. And of course, in real time, through our telepresence capabilities, I was communicating with Andy Armstrong, who was sitting at the Exploration Command Center on shore, and Andy was sort of our channel to the larger ECS program. And he was watching the sub-bottom data come in, again in real time. He's watching the CIS multibeam acquisition data come in. And he's telling me on the ship, okay, Mike, well, here's where our survey priority area ended, but here's where I want you to extend these lines looking for the base of slope, right? Or where essentially the extended continental shelf ends, the abyssal plain starts. So it was a great use of our telepresence mapping modalities. And finally, we have our last cruise just this past December, mapping deep water areas in the Caribbean and South Atlantic Bight. So one of the things I'll point out, and I'm sure you're noticing with these maps, is we have a lot of kind of long transits. We'll do some mapping, then we'll have some other long transits. Well, during these transits, and this is now becoming popular, or I think many of us here recognize years ago we should have been doing this, and that is during our transits, we have our multi-beam on. We are always collecting data. We are always mapping. If the ROVs are not in the water, our multi-beam is acquiring data, and we have our control room staff with our watch leads, with ourselves, right, acquiring and processing this data. And here's why. Shannon and I actually planned the strategic transit from Puerto Rico to the Bahamas, running over some interesting features that we see here in the seafloor altimetry, which is the lower resolution grid. Running this feature over, now if somebody or someone else were to go back there with some sort of research-driven, hypothesis-driven research, well, now they have a starting point to at least know how high this feature is and potentially what it looks like. In addition to some strategic mapping, we got to fill in another Aspire priority area. So Derek touched on our Aspire campaign. And again, what we saw are these possibly biogenic mounds, or mounds we know that tend to have some high density coral on there. What was wonderful about this was our office hosted an Aspire campaign workshop back in November, getting some white paper, some input from the community. And we kind of said, okay, we're going to be in the Atlantic. We want to work with everybody. Where do we want to go? How do we leverage our technical abilities? Well, this area was identified as a high priority area off the US Southeast. And within 30 days, our ship was able to go out there and get that data. And again, providing actionable, timely data to the scientific community. And some really fascinating areas in here too. Not an easy area to map, a lot of sound speed issues with the Gulf Stream. Also on this cruise, we had some folks. You go back from there. Just let it settle for a minute. Also on this cruise, we were working with some folks from CCOM doing some multibeam characterization. So we have a number of models that predict how multibeam, the sound from the multibeam actually propagates through the water column, but there's not a lot of empirical data out there. So we were working with Larry, Mike, Kevin, Jere here. We had a deployed JASCO hydrophone. We were working within the tongue of the ocean at the Autech hydrophone range, trying to gather actual empirical data on how the multibeam changes the ambient soundscape. Thanks. And let's see what goes. All right. Common theme in all these, this presentation today has been our community-driven exploration. When we're out there, we're always looking to do things like surveys of opportunity. We go to some pretty remote places. So if there's something else we can leverage our technical assets to do in an exploration sense, we're always open to it. This year, one of the examples we had was we were working in the US Southeast. We're also in partnership with the Deep Search Program, which Derek touched on earlier. And they had this benthic lander that had popped up way before its time. And so they said, well, we have this 700-pound benthic lander floating out there. Can you help us out? Can we go grab it? And so within 48 hours of this thing being popped up, we were able to drive out there and pick it up. A little tricky, but we do these things all the time. So if there's anything, we've also done Argos buoys. We do other surveys of opportunity. So definitely a community-driven platform. And finally, while this is a smart part of our job, our office has divisions dedicated to engagement, dedicated to education and outreach as a large part of what we do. So here you have a class from BC, Boston College, that actually helped us plan and execute a dive, an ROV dive in the Gulf of Mexico. A lot of these ports we go to, we're hosting public events and ship tours. And again, on a typical mapping cruise, you'll have some of the core mapping team watch leads. We'll also have our explorers in training. We'll have visiting scientists. This year we were fortunate enough to host a teacher at sea. So we have a number of people that we also are bringing into the fold, training and engaging with. Sort of winding down here, but just wanted to touch on one of the things our office has been looking towards and has manifested itself in some cruises on the Okeanos Explorer this year is emerging technology. So we have these cruises dedicated to emerging technology in the ocean exploration realm. This is a project we had from the University of Rhode Island. They came out and they actually brought a 3D printer, resin-based printer out with them that they had on a gimbal, and they were testing how this printer responded to the ship's motion, right? Ships move in a lot of different ways. And so what they actually did was they printed a series of test prints, and then in the end were able to fabricate totally offshore these depth chambers. And then we were able to send these depth chambers to depth on our CTD Rosette down to 200 meters. They came back perfectly dry inside. So as far as we know, this is the first time that something has been 3D printed at sea and then tested to depth at sea on the same cruise. It was pretty exciting. They were a great, these URI folks were a great group to work with. Another two examples are the temperature and acoustic data we collected through a towed fiber optic cable. So this allows for continuous measurements of temperature in the water column, right? So some real dense data of temperature in the water column, allowing us to get a high resolution 3D structure of what temperature looks like. And then we're also testing of a mid-water profiling system that had a number of sensors on there, measuring environmental parameters and taking images of some organisms. Looking ahead to 2019, as I've already alluded to, we're looking to integrate some new EK80 wideband transceivers, fishery split beam sonars, 38 and 70 kilohertz on the ship. Right now we use a trigger jigger, which is kind of old school to sync our sonars. We're looking to integrate a Kongsberg K-Sync to run all these sonars without interference. Sampling capabilities, we're looking at adding a suction sampler for the remotely operated vehicle. And then, of course, we're going to be replacing our 38 kilohertz ADCP, which had a tough year this year. And like I said, the ship's going to Pascagoula. Best thing about Pascagoula is $100 gets you 50 pounds of crawfish, and they are wonderful. And I will note, because of the government shutdown, we are a federal agency. Our schedule may or may not change. We'll see. But currently, we're planning to revisit some areas in the U.S. Southeast, Bermuda, New England seamounts, and we're also looking to get out to the Mid-Atlantic Ridge. We'll see what happens this year. We're actually still adjusting the schedule as I speak. And just a couple of people we need to acknowledge, and that's, of course, the crew and officers of the Okeanos Explorer. We couldn't do any of this without them. Global Foundation for Ocean Exploration, supporting ROVs, supporting our telepresence capabilities, supporting data management, and of course, UCARD and the cooperative programs for the advancement of Earth and Earth system science, These are the folks we work through to get out our EITs on the ship, our science leads on the ship, and of course a number of others here as well. And with that, I think we'll end with one of our big videos, or one of our highlight videos from the Gulf of Mexico.
Truly magnificent garden of coral fans. I don't think we've seen densities yet today, possibly not yet on the expedition.
Yeah, certainly we haven't seen these densities at these depths, so we're at 2,300 meters here.
Really dramatic terrain on this ridge top. Maybe it's these more vertical setting creates sort of microhabitat that initiates these denser columns of bamboo coral we're seeing.
So we're moving over here, you can see all the fans are lined up. That gives you an idea where the currents are coming from.
These fans are likely hundreds, not over 1,000 years old, so that gives a sense that although the slope's unstable, these blocks have been in their current position for quite some time.
I think this is a really good illustration that you need a lot of factors coming together in order to find the identity. You need to have the right underlying geology, you need to have the current flow, you need to have the food available, and you need to have the recruiting corals in an area that is stable enough that they can grow for a long period of time and get geology, large, whole colonies. To my recollection, we haven't seen anything quite like this in Gulf of Mexico so far.
We're starting to see all the different things that have to come together to make really great communities, and those are going to help inform models of coral densities in the future. We can become even better at predicting where we may find communities like this, planning our exploration times accordingly.
So coral kumbaya there. So do you guys have any questions about what you heard today?
Yeah.
For your ROVs, what limits how often you can dive with those on cruise? Just there are other reasons.
Staffing is a staffing issue. Yeah, the ROVs themselves can be in the water indefinitely, but they're not limited really by anything. It's really how we staff the ship functionally that limits how long those ROVs can be in the water. Sometimes we'll do extended dives. That's really what limits us. Yep.
Yeah, and we only have so many beds on the ship for the teams that it takes to run the vehicles and do the mapping. So we've ended up on an operational model where we're diving about half the time, and then we're mapping typically overnight to the next dive site. But yeah, it's definitely possible to do extended work. Mm-hmm. The trade-off, of course, is if you do a longer dive in one area, you're only looking at a very small area and you're not exploring. Right. We really try hard to get a broad diversity of dive sites through different habitats and throughout a broad geographic region.
So,
does that argue for having an AUV in lieu of an ROV? You could put down and go do mapping and come back and collect it a couple of days later and maybe have the capability to hover a bit and get the kind of footage that you like to get, versus have to talk to some technology to identify what you're looking for and figure out what you want to stop on. But
yeah, no, absolutely. I mean, our office is 100% interested in advancing AUV technology and bringing that into our operational model, but it's not quite there yet. Of course, the ROV offers some capabilities in terms of bringing, because we can live stream what the ROVs are seeing. That's a huge engagement benefit for us as a program. And then, of course, the sample collection is another big piece that has a lot of value to the science community, but definitely in terms of being able to get a lot more imagery and a lot more ground truthing about what's on the seafloor, AUVs would be a huge benefit, as well as more high resolution mapping. So
we are actively interested in incorporating AUV and ASW technology within our toolbox. Yeah. Yeah.
If you're going from one destination to another and mapping along the way, do you have to use to map?
Depends on what our priorities are. If we're mapping along the way and we're mapping some sort of pre-identified priority area, we'll slow down. Typical mapping speeds anywhere between 8 and 9 knots. But if it's one of those jump dives and we just have to get to the next dive and it's 110 nautical mile transit, we'll go at 10 knots. Depending on what the seafloor morphology is and the physical characteristics of the seafloor, sometimes it's really not that bad of poor data, but sometimes we just got to get to where we're going. So it's always a trade-off, right? Yeah. So our dives are pre-planned in so fact as they are exploratory because we're not diving anywhere like whether it's been repeat dives, but of course as we've kind of highlighted, right, we are engaging the community, right? So before we go out there and we're saying, okay, we're going to the Atlantic, canyons, which canyons would you like us to dive in? There have been no remotely operated vehicle dives, right? We'll identify it there. And then, in the morning, we'll actually get there, and depending on how the physical properties of the wind waves, they all set up, sometimes we can dive on the exact dive site somebody suggested, or at least within the same canyon. Yeah, so we do go through a whole community outreach process asking, okay, here's our operating area. Where would you like us to go? Where has there been no work before?
Yeah, but that is one of the course filters for that process is this truly exploration or is this somebody's sort of pet research project or repeat measurement? We do try to keep always that what is this benefit to the larger exploration mission? And then we do actually plan some stuff on the fly. I mean, stuff, yeah. Yeah, there's typically every RV cruise we have a couple that are map and dives. Like we'll map overnight, and then we're up in the wee hours of the morning trying to make a good map for the RV team to dive on safely. But that's pretty risky because if you don't find something, you don't want to dive on a flat, muddy bottom and bore everybody. So
and sometimes we'll get depths. We don't care where you dive in this region, but we want to be between 2,000 and 1,000 meters in depths. And so we'll say, okay, well, the sea mount based on the satellite altimetry looks like it could be, within that region. We'll map it, and it could be, 500 meters taller than we actually predicted. But then you're stuck diving there in any event, right? You're there now. So yeah, I mean, it is. We do some map and dives. Yeah, it was a lot of fun. Yeah. So that was great, and maybe I should have made a clarifying point. I appreciate you bringing that up, right? So they're likely associated with methane hydrates, because that's what we've seen before, but the actual composition of what we're seeing in the sonars, right? Typically we see things like methane bubbles, but you're absolutely right. Until we actually send the vehicles down there or we're actually sampling that, we don't know what the composition of these things are that are actually scattering the sound within the water column data itself.
So usually, a lot of times we'll call something a bubble seep or a gas seep. We won't try to define its composition because it's not measured.
Yeah.
So when you take water samples before chemistry?
We are working towards that capability.
We have a water sampler now, but it's we don't have a normal way to sample gas.
Yeah.
We have in the past some collaboration with Tom Weber here, but there was kind of an ad hoc device made to collect the bubbles, but typically we're just collecting more like the biology, the geology, and then recently some water samples. Great. Well, if you have any follow-up questions, Mike and I and Shannon and everyone in the meeting, which is back, work here, and we'd love to talk with you more. And all this data is publicly accessible. If you want to do some analysis of it, there's a lot of additional interpretation that could be done with the public data.
If you got things that you want mapped.